Hello everyone, welcome again in Artificial Intelligence class. Well, in this particular lecture we will discuss Bayesian network is. Well, before we start discussion, here you can see the agenda of the class. First of all, we will discuss a Bayesian network. Then after this we will see what is a directed acyclic graph and why it's important in the creation of Bayesian network. Then after this we will see the math behind Bayesian networks, and then after we will understand a Bayesian network with some real world example, and then after this we will implement Bayesian networks with the help of Python language. And then in the end of the series of the lecture you can find one of the lecture on Bayesian network application. So these are the series of the lectures you can find on my channel. Well, let's get started. What Bayesian network actually is. So here you can see the definition. A Bayesian network falls under the category of probabilistic graphical modeling technique, PGM, that is used to compute uncertainties by using the concept of probability, right? So here you can see, popularly known as belief network, Bayesian network are used to model uncertainties by using directed acyclic graph. So you need to understand the main and then the most fundamental concept behind Bayesian network is probability. So probability is a pretty simple concept, right? And a lot of mathematical models are actually based on the concept of probability. Now you might have heard of Bayesian network as belief network and as causal networks, right? So they are also known as, we can say, the Bayesian network also known as causal network and then the belief network, and they are used to model uncertainties, and they are used to model uncertainties by using directed acyclic graph. Now it is might be, I think, seem a little confusing, or the definition might seem a little ambiguous to you know what I am saying, and that they are used to model uncertainties or they are used to model unknown values. That might seem a little vague to your mind, but I will be explaining this with an example, so don't worry. Now all I am telling you is that of a Bayesian network is based on the concept of probability, and the concept of probability, and it can be represented by using a directed acyclic graph. Simple. Again I am repeating, I am saying Bayesian network is based on the concept of probability and it can be represented by using a directed acyclic graph. So let's understand what is directed acyclic graph and how we can represent Bayesian network. So here you can see a simple example. Suppose this is a graph x, y, z, and this is a. So suppose this is a Bayesian network, yeah, we can say belief network. As you know, in the belief network we have DAG, and in the DAG we have nodes, and then the second one is arc, the node and then the arc. If I talk about the nodes, so nodes actually correspond random variable, and it may be continuous and it may be discrete. So nodes are the continuous random variable corresponding random variable, and it may be either continuous and may be discrete. And if I talk about arc, so arc may be directed arrows, and it represent actually causal relationship, or we can say conditional probabilities among variable. I am writing here conditional probabilities among variable. So here you can see the dependent and independent, dependency and independency. Well, if I talk about A is independent because it has no relationship with x. So we can see here A is independent of node x, and if I talk about y and z are dependent on x because it contains some relationship with x, because x is the parent of y and then the node z. So these are the relationship in the directed acyclic graph and arcs show the relationship, and it's showing the dependency and independency of the nodes of the variable. So node A is independent, but the node y and z are dependent on x because x is the parent node of y and z, but there is no relationship with x and then the a. So this is the little bit explanation of how we can represent directed acyclic graph, how we can represent Bayesian network with the help of DAG. Welcome to the lecture again. Here you can see Bayesian network actually it defined probabilistic independency and dependency among the variable in the network. It is a probabilistic model which represents a set of variables. As I already told you, nodes are the set of variables in the graph and their conditional dependency using a directed acyclic graph. Built from probability distribution consists of DAG and table of conditional probabilities. Actually, we can design Bayesian network with the help of DAG and with the help of conditional probability table. So you can see in next lecture what is conditional probabilities and how we can represent a Bayesian network with the help of a table. Well, let's see what are directed acyclic graph. Here you can see the little bit explanation. Let's understand what exactly is DAG. So take a look at this diagram. Here you see a couple of nodes 1, 2, 3, 4 basically represent a node. The arrow directing from each of these nodes represent the relationship between these nodes. If you look at the figure, you can see that the node 3 is dependent on both node 1 and 2. Alright, because you can see links or you can see arrows directed towards number 3, meaning that number 3 यानी कि node 3 कह सकते हैं कि node number 3 is dependent on 1 and 2, or you can also say that 1 and 2 are the parent node of node number 3, right? Similarly, you can see here the node number 4 is dependent on node number 3, right? Which makes node number 4 the child of node number 3, यानी कि 4 is the child of node number 3 and node number 4 is dependent on node number 3. That's all we all can understand by just looking at the figure. We learned all of this in probability actually in our 10 standard. Right, so like said that the node represent random variable and the age will define basically the relationship. Node represent the random variable and the age will define the relationship between the variables. But the question is, what do these graph model and what output can you get from a directed acyclic graph? So a DAG will basically value the uncertainty of an event occurring based on the conditional probability distribution of each random variable. So a DAG models the uncertainty of an event occurring based on the conditional probability distribution, as I already told so far, of each random variable, and a conditional probability table is used to represent the CPD of each variable in the network. So we will use actually for the implementation of DAG, we will use the conditional probability table, conditional probability, and the second one is joint probability, and with the help of these two mathematical probabilities we will design our Bayesian network. Now I know some of you might get confused to go to know what conditional probability and what joint probability. We will discuss in other lectures. Thank you.